Hi everyone, myself Jyoti Prasad from RMD Engineering College. We are going to discuss about operational amplifiers, how many types of configurations. So earlier we have discussed about the operational amplifier and what are the input terminals, output terminal with respect to pin configuration. So in this 8 pin op amp 741, we have second pin as an inverting input, third pin as a non-inverting input. So we are going to operate this operational amplifier in two types of configuration: open loop configuration and closed loop configuration. So open loop configuration is nothing but there is no feedback, right? What we have seen in the what we have shown in the top of this right corner. So we will have only op amp, voltage v1 v2 are the inputs and v0 will be the output. We don't have any feedback from output to input. So that type of configuration is called open loop configuration. So we can use op amp in other configuration also, which is called closed loop configuration, where do we have feedback and we are going to arrange a resistor from output to input. So we are taking feedback from output to input. That type of configuration is called closed loop configuration. So coming to the configurations, open loop configurations, we have much very simple operations, but many of the applications are in closed loop configuration only. So coming to the feedback, we will have a doubt that we should go for positive feedback or negative feedback. So normally every student will have an idea of that. Negative feedback is used for amplifiers. So we are going to use the same feedback. For example, two voltages are there here for us for an op amp: positive terminal and negative terminal. So what will be the output of an operational amplifier? So for a simple input, so even though both are same, both are different, for any case we can see the output. So if V1 input is greater than V2, the output is plus V saturation. Why? Because V1 is V1 is at positive terminal. So if V1 is greater than V2, the resultant amount will be a positive quantity. So the output will be plus V saturation. So if see, like I said, V1 is applied at non-inverting terminal. Non-inverting terminal is plus. V2 is applied at inverting terminal, is nothing but minus. So if at all V1 quantity is greater than V2, then positive saturation voltage plus V sat will be the output. If at all V1 is less than V2, that means positive terminal input is less than negative terminal input, then output V not equal to minus V saturation. So which results in this type of waveform. So at one point of time, if your input is sinusoidal, V1, V2, both are varying, then output will be like this, a square waveform. So plus V saturation when V1 greater than V2, and minus V saturation here, the down one, when it happen means V2 greater than V1. So likewise, sine to square waveform generator also one of the application. So the main applications of the operation amplifier in closed loop is it will act as a switch, and major application of the op amp is comparator. Comparator, like we have seen comparing operation V1 greater than V2 or V1 less than nothing but V2 greater than V1. So which leads to zero crossing detector. So these are many applications of op amps are there: sign changes, scaler, subtractor, adder. We can perform many of the operation, basic operations. Okay, so like I said, we are going to do or utilize a negative feedback in the circuit, so which will behaves as a linear manner. Okay, so why? Because we are going for negative feedback means this closed loop configuration controls input resistance, output resistance, bandwidth, offset voltage. So these are all the considerations we are going for negative feedback. While we are analyzing for our op amp analysis, the the two assumption has to be done. The first assumption is the difference between two inputs should be zero, VD equal to zero. So the difference should be zero. That is the main ideal op amp characteristic also. The second one is the current drawn by either input terminal is negligible, zero. Current drawn by any first terminal I1 equal to zero, second terminal I2 equal to zero, any terminal, the current drawn by the terminal is zero. These two assumptions we want to take, and we need to perform the analysis. So in closed loop configuration, we will have three types. I mean, we are going to use op amp as an inverting amplifier or non-inverting amplifier. Both the inputs are present, V1 and V2. Then it will be acting as a differential amplifier. So first we are going to see inverting amplifier in this for particular slide. So like I shown here, I have given input for the negative terminal. I have made the positive terminal nothing but non-inverting terminal as a ground. So if we made non-inverting terminal as ground, only we are giving input to inverting terminal. That seems to be inverting amplifier. So like I said, RF is a feedback resistor taken from output to input. And what is this? RN means current limiting resistor. Through current limiting resistor, we are going to give the input V in through negative terminal, non-inverting terminal. Sorry, my main inverting terminal. Okay. So first of all, we are going to see about input. V in is nothing but IR. So input current across the R in resistor is I in. So multiplication of both the things gives a V in value equal to V in value. So from that one we can rewrite as I in. So if I want to write an equation for output, means V out is equal to, so minus I in into RF. So this current through this feedback resistor, we can take it as the output voltage. So minus I into RF. So if we substitute I in this particular equation, minus V in by R in into RF. So we know the ratio RF by Rin. RF by Rin is nothing but open loop gain. We will call it as open loop gain, RF by Rin. So if I substitute open loop gain AOL, then the output equal to open loop gain into Vin. So here the open loop gain is minus RF by Rin. AOL is nothing but open loop gain of an op amp is nothing but minus RF by Rin. Okay. So here why we got minus, we will have a doubt of that. V out is equal to, if I take the practical value also, 10 kilo ohm as an op amp feedback resistor, 1 kilo ohm as an input resistor. If I take that, substitute the values, minus 10k by 1k into 1 volt input, positive 1 volt we have given, the output is minus 10 volts. So like we said earlier, the operational amplifier will works as an amplifier, comparator, all those things. So amplification have been done. If I have given 1 volt of input, due to this open loop gain of minus 10k by 1k minus 10, so we got minus 10 volts. So amplification is done, but why, what is the minus here? 180 degrees phase shift will be done. So minus. How why minus k means we are operating this op amp in inverting mode. We have given input to inverting mode. If at all we have seen this one as with an example, see, if an inverting amplifier with input voltage of 2 volts, feedback resistor 5 kilo ohms, and input resistance is 1 kilo ohm. So calculate the output voltage like we have seen. So see, Z is a two input, 2 volts peak to peak. So 1 volt at positive, 1 volt at negative. 2 volts peak to peak is applied to this particular op amp which is operating in inverting mode, with feedback resistor 5 kilo ohm, 1 kilo ohm. So we know AOL, open loop gain is nothing but minus RF by Rin. So if we go minus RF by Rin means minus 5k by 1k minus 5. So and input is 2 volts. So minus 5 into 2 volts minus 10 volts will come. So minus 10 volts means we have given input 2 volts, got amplified in inverting mode, and the output is minus 10 volts. So because of this minus 10 volts, the output looks like this. See, plus 5 volts for positive portion, but the starting point is minus 5 volts. This minus is becoming 180 degrees phase shift. So the output starts from here, 180 degrees phase shift. So the negative half carrying 5 volt minus 5 volts, positive half carrying plus 5 volts. So peak to peak 10 volts. Thank you.